Hello everyone. Welcome to our video presentation on analyzing a complex structural engineering problem. In this project, we were tasked with designing and analyzing the basement roof structure by comparing determinate and indeterminate beams. Our goal was to determine which option is more economical and safer. Let's dive into the details. To accomplish this, we analyze both simply supported and continuous beams. In our scenario, the slab above the beams is a one-way slab, as shown in this shaded region, which represents the specific beam under consideration. Here is the sectional view of the basement. We evaluated two options. 1. Providing 15 feet long 6 simply supported beams, which do not continue over the interior columns. 2. Providing 30 feet long continuous beams, which extend over the interior columns. The dead load for the structure is 25 pounds per square foot, and the live load is 125 pounds per square foot, resulting in a total load of 1.875 kips per foot for both beam types. Our simply supported and continuous beams will now appear as follows. Initially, we calculated the load without factoring in any safety measures. However, as per steel structure design requirements, we applied the factored load combination to consider the worst-case scenario. After including the self-weight of the beams, the total factored load came out to be 2.91 kips per foot. Now this loading is with factored load combination. We then converted the units from kips per foot to kilonewton per meter and manually analyzed the simply supported beam to determine the maximum shear force and bending moment. Using the same approach, we analyzed the continuous beam. Subsequently, we performed a software analysis using SkySieve to compare the results with our manual calculations. Based on these analyses, we proceeded to design the steel beams. One challenge we faced during the design process was lateral torsional buckling in the compression flange of the I-shaped steel sections. To address this, we proposed continuous bracing using wooden beams placed on top of the steel beams. Since the clear spacing between the wooden beams was not specified in the project, we used engineering judgment. This resulted in a configuration with frequent wooden beams along the span, effectively providing continuous lateral support for the compression flanges of the steel beams. Let's talk about final results. Stability comparison. Simply supported beam. Stable under normal conditions, resists bending moments and shear forces but experiences larger deflection. Maximum deflection, 12.24 mm, W200 by 52. Continuous beam, more stable and resistant to deflection due to additional supports, offering better load distribution and rigidity. Maximum deflection, 5.65 mm, W200 by 46.1. It is recommended continuous beam, W200 by 46.1, is preferred for the 30-meter span due to better performance under safety and serviceability limit states. Final selection, W200 by 46.1.